Today we are going to look at lesson 8.5 and we are going to learn the final form of a quadratic equation or a quadratic function. Now, before we move into this new form, let's go back and talk about the two forms that we've already learned, all right? Try not to look ahead in your notes because it's in your notes, all right? The first form you learned in lesson 8.3 was the standard form. Does anybody remember the standard form of a quadratic equation? F of x equals ax squared plus bx plus c. Very good, all right? Yesterday we learned vertex form. Does anybody remember vertex form? If you can't remember it, you can look at your notes. But what was the vertex form that we learned yesterday? F of x equals a times x minus h squared plus k. Now remember vertex form. We were able to pull the vertex straight out of the formula. We didn't have to do any extra work to find the vertex. But what did we have to be careful of on the vertex form? When we pulled h out, we had to pull out what? The opposite of what we saw. All right? So the essential question for today says, what are some of the characteristics of the graph of f of x equals a times x minus p times x minus q? So this is our third and final form called the intercept form. Now you see right here in your notes, I have listed all three forms. All right, so I want you to take your highlighter and I want you to highlight standard form, vertex form, and intercept form. And if you want to make yourself this note, make yourself this note. These three forms will be on your test and or your quiz. It could be on one, it could be on both. But you need to know all three forms, the name of the forms, and the actual formula. Okay? Now, we've already kind of talked about and reviewed standard form and vertex form. Let's look at intercept form a little bit closer. It says h of x, and we know that can be f of x, g of x, h of x, but it equals a times x minus p times x minus q. And notice what it says. P and q are the x-intercepts. So I want you to highlight the p, and I want you to highlight the q, and then I want you to highlight this, let's just highlight x-intercepts. And let's review what we know about x-intercepts. What are x-intercepts? If we were putting x-intercepts onto a graph, what are x-intercepts? X-intercepts are points. So if you are not clear on that, then underneath x-intercepts, just put the word points. Just like the vertex is a point on your graph, the x-intercepts are points. Now, where do these points fall very specifically? If they are x-intercepts, they're the point where your graph does what? Okay, these are the points where your graph crosses the x-axis. Okay, so these are points where your graph crosses the x-axis. Now, let's look at how we graph a quadratic function using this form. Keeping in mind that we usually will use Desmos, but what if Desmos is not available? Or what if we're just asked to identify the vertex and the axis of symmetry and the intercepts and we don't need Desmos? We're not actually going to graph anything. All right, here are the things you need to know. First of all, we have to find the coordinates of the vertex. Now, once again, it's not as easy as pulling things out of the formula. So look at what it says. It says to find the x-coordinate of the vertex, you use the formula. Now take that highlighter and highlight because we have a new little formula. Remember with standard form, we did x equals negative b divided by 2a. All right? This is different. Same kind of idea. There's a little formula to help us find x, but it's p plus q divided by 2. All right? But then look what we do with that x-coordinate in order to find y. What do our notes tell us? Or what do you think, without even looking in your notes, what do you think we're going to do with the x-coordinate in order to find the y-coordinate of the vertex? We're going to plug the x back into the original problem. And that's exactly what the notes say. To find the y-coordinate, we plug the x-coordinate back into the original problem. Now, the next thing we have to do is write the equation of the axis of symmetry. Now, guys, we have been going over this, and I'm really hoping that it's in there. All right, what do we know about the axis of symmetry? First of all, if I'm putting it on a graph, it's a what? And don't say dotted line. It's a vertical line. Good, okay? Which means that when we write the equation of that vertical line, it always has what variable in the equation? x, okay? So if you are still unclear about this, please add this to your notes one more time, all right? The axis of symmetry is a line, and that line is x equals something, okay? It's x equals some value. Now, what do we know about the value of the axis of symmetry and the x coordinate of the vertex? They are exactly the same, and that is in your notes. Because look, it says use the formula. That is the exact same formula that we just highlighted when we want to find the x coordinate of the vertex. So that should tell you right there, the axis of symmetry and the x coordinate of the vertex are the exact same number. Okay, you use the formula x equals p plus q divided by 2. And then it says the axis of symmetry is also the x coordinate of the vertex. So let's highlight that too. Let's highlight axis of symmetry, x coordinate of the vertex. We're just going to keep highlighting and keep pointing these things out until it just is natural for us to do. Now, there's a third thing we have to do. So far, when we've graphed a quadratic function, we've definitely graphed the vertex, we have definitely graphed the axis of symmetry, but we've picked our other 2 points randomly, right? We have found 1 point on either side of the axis of symmetry. Well, in this form, the 2 points are given to us. We have to find the 2 x-intercepts, and those are the points that we're going to graph. Now, look at the formula once again. F of x equals a times x minus p times x minus q. And you can see in your notes how I bolded the p and the q. Go ahead and highlight them again. We just want them to stick out. The p and the q are your intercepts, the x-intercepts, to be very specific. Now, what do you notice about the sign in the formula? Once again, this is kind of like yesterday with the vertex form. In the formula, there is what sign? X minus the p and x minus the q. So what do you think has to happen when we pull p and q out of the formula? What are we pulling out of the formula? The opposite number. So I want you to highlight, pull out the opposite number. Because here we are again. When we go to identify the 2 x-intercepts, we pull out the opposite of what we see, because the formula already has a minus sign in it. So that's why we have to pull out the opposite of what we see. Now, there's one more thing you need to know. When I'm identifying the x-intercepts, we've already said that x-intercepts are what on a graph? Points, right? So that means we have to represent them as a what? Our final answer needs to be written as a what? An ordered pair. And that is right here in your notes as well. So star this, highlight it, whatever you need to do, but make sure you remember your final answer for the x-intercepts is going to be an ordered pair. Now look at those 2 ordered pairs. What do you notice is the same about both of those ordered pairs? P comma 0 and Q comma 0 are your x-intercepts. What do you notice about both of them? 0 is the y value. So again, I would do something, you can highlight, draw an arrow, do something to where that sticks out. Okay, but anytime I am giving the x-intercepts, the y-coordinate has to be a 0. Now, example number 1 says, graph the quadratic function, label the vertex, the axis of symmetry, and the x-intercepts, which, whether the directions tell us to or not, we've been doing this. We label our points, we label our axis of symmetry, and then they want us to describe the domain and the range. So we haven't done that since 8.1 and 8.2, so we're going to pull that back in to our lesson today. But what did I write next to letter A? No Desmos. So your phones should still be in your pockets or turned upside down or under your chair. We are not using Desmos yet. All right. Instead, we are going to use the information that we just went over in our notes and highlighted, and we are going to find these things by hand on paper, the good old-fashioned way. All right. So no Desmos right now. Let's start by finding the vertex. What is the formula that we are supposed to use to find the x-coordinate of the vertex? Okay, so x equals p plus q, excuse me, divided by 2. All right, now be very careful, because remember, when we pull out p and we pull out q, we're pulling out the what? The opposite of what we see. So, alphabetical order, P is first, Q is second. What is our P value in the given problem? All right, we see plus 2 right here, and if we're pulling out the opposite of what we see, we're pulling out a what? Negative 2. Good. And then it's plus, what do we see in there for Q? We see minus 3, but if we're pulling out the opposite of what we see, we're pulling out a what? A plus 3. And then we're dividing it by 2. So what's negative 2 plus 3? 1. So x equals 1/2. Now, we're going to go ahead, because we know this is the x coordinate of our vertex, we're going to go ahead and start that ordered pair. What have we already found, too? Because the second thing we're supposed to find is the axis of symmetry. Do we already have the equation of the axis of symmetry written? Yes, we do. Look at that right here. We can box that in if we want to. There's your axis of symmetry. When you found the x coordinate of the vertex, you also found the axis of symmetry. So let's just go ahead and box it in right there. Now, what do we do with the x coordinate? Because we still need the y coordinate of the vertex. So what are we supposed to do with that 1/2? Plug it back in to the original problem. So the original problem was f of x equals, we had x plus 2, so we're plugging in 1/2 plus 2 times x, which again we found out was 1/2, minus 3. So we're plugging 1/2 back into the original problem. Now we got to do some math, and we should be able to do it without our calculators. What is 1/2 plus 2? You're adding a half and a 2. 2.5. Very good. So in our parentheses, we have 2.5. And you know what? Well, we'll do that here in just a second. So we've got 2.5 times, what's half minus 3? Now the signs are different, so we're going to add these numbers or subtract them? Subtract them. So think 3 minus a half. We can rearrange the order to do this part. Negative 2.5. Good. It's negative because 3 is larger, but it's negative 2.5. Now, we cannot multiply mixed numbers. If you remember that from elementary school, we cannot multiply mixed numbers. So let's make them improper fractions. What is 2.5 as an improper fraction? 5 over 2. Because remember, you do 2 times 2 plus 1. And then what is negative 2.5 as a improper fraction? Negative 5 over 2. Now we should be able to multiply them very quickly. What is 5 times negative 5? And what is 2 times 2? 4. So we have just found, and you can circle, don't box it, but we have just found the y coordinate of our vertex. So we go back up here to our ordered pair, and we write negative 25 over 4. Close up the ordered pair, and we can box it in, because we're going to have to put this on our graph here in just a minute. Now, the only thing left for us to find then, number 3, are the intercepts. The intercepts, we're going to write our intercepts as what? Go back and look at your notes. What did we highlight? The final x-intercept has to be written as a what? Ordered pair. So what if we went ahead and put 2 sets of parentheses, and we already know our y-coordinates? What's our y-coordinates? 0. So we can go ahead and put a 0, and we can go ahead and put a 0. Now, we have already pulled these x-intercepts out once for that very first formula. So again, this shouldn't be too difficult. What's the first x-intercept that we're pulling out of the original problem? Be careful. A negative 2. Remember, we pulled out a negative 2 for that formula. And what was the second intercept that we pulled out? A positive 3. So there, again, very quickly, we can get our 2 intercepts, all from the formula that was given. Now, let's go graph this stuff. All right, we'll start with the vertex. Now the vertex is a little tricky because it's fractions. So either change them to decimals or change the mixed number to, change the improper fraction to a mixed number. Whatever will make this easier for you, it does not matter to me. But if the x coordinate is a half, then I'm going to go start at 0 and I'm going to go halfway over. So I can't go all the way to 1 because it's only a half. And then what direction do I move for the negative 25 over 4? Up or down? Down. Now, what is negative 25 fourths as a mixed number? 6 and a fourth. Very good. Negative 6 and 1/4. So I move over just halfway between 0 and 1. Then I go down to negative 6 and I go a little bit past negative 6. Okay? And you're going to have to just kind of guesstimate. It's a fourth. So it's a little bit weird. But as long as you label the point, I'll know exactly where you were going. Okay? So we're going to label this. And again, I don't care if you label it. I'm going to keep it as fractions. It does not matter to me what you decide to do, okay? And I know it's very tiny, and I'm very sorry. Now, let's go graph the other 2 points, -2, 0, and 3, 0. So we start in the center, we go left to -2, and we stay on the x-axis. And then we, from the center, go right to 3, and again, we stay on the x-axis. That's why they're the x-intercepts. And of course, we're going to label these. So we're going to label this as -2, 0, and we're going to label this one as 3, 0. Now, axis of symmetry. The axis of symmetry goes right through the what? The vertex, okay? So again, this should not be super difficult. We've already got our vertex down here, so we're halfway between 0 and 1, and we're just going to make sure, and we're going to take this all the way from the bottom of our graph to the top of our graph. We're going to put arrows on it, and we're going to label it. Now, I'll label it at the top. You can label it at the bottom, but we label it as x equals 1/2. Remember, we're putting the equation of the axis of symmetry next to it. Now, the only thing left to do is draw the parabola. Our parabola is what shape? U-shape, okay? Make sure that it's not V-shaped. V-shaped is a very different type of graph, all right? And if you're anything like me, for whatever reason, I tend to struggle on the iPad to actually draw right, so I'm going to do my best. You guys do your best and put your arrows on the end. Now that leads us into domain and range. What did we learn about the domain? As long as there's arrows on either end of our parabola, what's our domain? All real numbers, because the graph goes off in both directions forever and ever. So x can be anything. So all real numbers. Now range, what variable goes in our range? Our y. And this parabola opens up or down? Up. So our inequality symbol in the range, greater than or equal to or less than or equal to? It opens up though. Greater than. Remember, let it make sense. If the parabola opens up, then we're using greater than or equal to. Now, what is it greater than or equal to? -25 fourths, or if you want to use the mixed number, greater than or equal to -6 1/4. And this is the domain and range that you want to plug in. So, do you see the process if we did not have a thing called Desmos? This is the process that you would have to use. All right, you need to know this process because, like I said, I might not ask you to graph. I might just ask you to tell me what the vertex and the axis of symmetry and the intercepts are. So you want to be able to do it without Desmos. But for letter B, grab your phones, open up Desmos, and graph letter B. Same pieces of information. You still want the vertex, the axis of symmetry, and the x-intercepts. But you can use Desmos this time. I'm not going to pull up Desmos. I'm going to let you guys give me the information that you need by using your own Desmos. Let's start again with the vertex. What did you find as the vertex on your graph in Desmos? Zero, 8. So we start in the center and we go up to +8 and we plot the vertex. All right, what about your x-intercepts this time? What are your x-intercepts? All right, -2, 0. Is that what you said? -2, 0. And what's the other one? +2, 0. Good. So we'll plot those. We'll label those 2, 0 and -2, 0. All right, what about the axis of symmetry? What's the axis of symmetry equation this time? All right, x equals 0. So that means the axis of symmetry, we got to draw a little bit darker because it is going to be directly on top of the y-axis. Okay, but we still draw it from top to bottom, still put arrows on the end, and we still want to label it. Now I'm going to label it at the bottom this time since my vertex is up there. So x equals, what's the equation? X equals 0. Good. It goes through 0 on the x-axis, so the axis of symmetry is x equals 0. Now, this graph, does it open up or does it open down? This one opens down. So again, we're making sure that our line is curved as best we can. So sorry about my drawing skills. And the domain and the range. What's the domain of this parabola? Good. Again, if we have put the arrows on the end, we're showing that it goes off in both directions forever, so all real numbers. What about the range? Again, what's the variable in our range? Y. Now, this parabola opened up or down? So the symbol, the inequality symbol in my answer, in my range is what? Less than or equal to. And it's less than or equal to what? 8. The highest Y value, the high point, the highest Y is 8. So that is the value that goes in my range. And so that is my domain and my range. Now, when we move on to the next part of our lesson, and that's just what it looked like in Desmos, all right? We're asked to find the zeros, and you'll see I've added in parentheses next to the word zeros, x-intercepts of a function. Now, I want you to highlight this, and I want to talk about this for just a second. Remember how I taught you f of x can be replaced with what variable? With y, right? I've taught you that f of x and y are interchangeable. They're the same. They mean the same thing. Okay? So that is exactly what's happening here. I can ask you to find the zeros of the function, or I can ask you to find the x-intercepts of a function, and I'm asking you to do the same thing. So you need to know that, all right? So whether the directions on the quiz and test say find the zeros, or whether they say find the x-intercepts, they are asking you for the same thing. Now, here's the good news about this next type of problem. You have already been doing this. You have done this on 2 tests already. Here's the one difference. Step number 1, you've not had to do up to this point. It's already been done for you. So look at step number 1. We replace f of x with 0. Now, I use f of x loosely because what if it's g of x? What if it's h of x? Does that matter? No. I'm going to replace f of x with 0. Once I've done that, then I'm going to look at the other side of the equation, and I'm going to factor if it has not been factored already. And then the third thing I'm going to do is I'm going to set each set of parentheses equal to 0, and I'm going to solve for x. Now, do you see that? Do you recognize those steps? We have been doing this now for 2 tests. So this is not new information for you. Look at example number 2. It says find the 0 or zeros of the function. So look at letter A, and what's the first thing we're supposed to do? Change it to a, change what to a 0? F of x. So we have 0 equals, and we bring down x minus 6 times x minus 1. Now, factor if it's not already been factored. Has this problem been factored for you? Yeah, it's already the product of 2 binomials. So I move on to step number 3, and I'm supposed to set each factor equal to 0 and solve for x. So what is the first equation that I'm going to write? X minus 6 equals 0 and x minus 1 equals 0. How do I solve for the first x? I add 6 to both sides, so x equals 6. Now, circle, don't box. We'll get back to this in just a second. Let's solve the second equation. How do I solve for the second x? I add 1. So x equals 1. Now remember, circle, don't box, because I am finding the 0, which is also known as the what? The x-intercept, right? That's in our notes. We just learned that. Zeros and x-intercepts are the exact same thing. So Avery, how do I need to write this final answer if these are my zeros, also known as my x-intercepts? Yep, ordered pair. What is the ordered pair? 6, 0. And what is the second ordered pair? 1, 0. And those are the 2 ordered pairs that I box in. Those are my zeros. So zeros and x-intercepts are exactly the same thing. Now look at letter B. What do I do first? Okay, I change the g of x to a 0, and I bring down the rest of the problem. Now, I'm supposed to factor if it has not been factored already. Has this been factored already? No, so let's pull back into the front of our brain those 4 questions. What is question number 1 when we are factoring? So is there a GCF? Yes. What is it? 3. Good. So we're going to pull a 3 out, and then remember we take each term and we divide by the GCF. So what's 3x squared divided by 3? X squared minus, what's 12x divided by 3? 4x plus, what's 12 divided by 3? 4. Now, what is question number 2? Okay, remember now we're looking in the parentheses. What type of polynomial is this that we're trying to factor? Trinomial. What's question number 3? There's only one shortcut for trinomials. Does this one fall into that category of a perfect square trinomial? Yes. Look, first term and third term. Both are perfect squares. The second sign is positive, so So it appears as if it is a perfect square trinomial. So we're going to treat it as such. We're going to bring down 0 equals 3. How many parentheses are supposed to be in our answer if this is a perfect square trinomial? 1, and it's supposed to be raised to the second power. What sign is going to be in our answer? Good. Whatever the first sign in the problem is, that comes down into our answer. Now, how do we find the two terms of our binomial? Square root. So if you're still struggling, throw the square roots over the first term and the third term. What is the square root of x squared? X. And what is the square root of 4? 2. Now, before we get too excited and start setting up our equations, we've got to check. What do we use to check for the middle term? All right, so over to the side, we're going to do 2 times a times b. What is the a in our answer? X. Remember, the a and b come from the binomial. So what is the b? Negative 2. And together, when we multiply those, we get what? Was that the middle term of our original trinomial? It was. So we have factored correctly. Now, the only thing left is step 3. Set each factor equal to 0 and solve for x. What is the first equation then that we're supposed to write? What's the first factor? 3. Remember, the GCF is part of the problem. So we have to take the GCF and we have to set it equal to 0. Now, in this case, does that even make sense? Is that a true statement? No, so we're just going to cross it out and we're going to move on. What's the next equation we're going to set up and solve? And how do we solve for x? Add 2, and so x equals 2. But remember, this is not our final answer because the 0 is also known as your x-intercept, so the final answer has to be a what? What is the ordered pair here? 2, 0. Now, I want you to notice something. How many x-intercepts did our letter A have? And how many x-intercepts did our B have? That's okay, all right? Sometimes your parabola will cross the x-axis twice. Sometimes it will cross the x-axis one time. And guess what? Sometimes it won't cross the x-axis at all, all right? But this is how you find. Now, you've done this. So this should not shock you. This is nothing new. You've been doing this for a month now. But look at example 3. This is brand new. So stay with me, and I'm going to make it as simple as I can. We're supposed to write a quadratic function in standard form. So go ahead and highlight standard form because that's the final form that your answer should be in, whose graph satisfies the given condition. Now, before we move any further, let's write down the standard form. That way we have a visual of what our final answer should look like. Who can remember? You can look back or you can remember and just tell me from memory. But what is standard form of a quadratic function? Beautiful. F of x equals ax squared plus bx plus c. So when we box in our final answer, this is the form it should be in. Unfortunately, though, we can't start with standard form. We're either going to have to start with, we only have 2 more options, vertex form or intercept form. So we have to look at the given conditions and we have to decide, do I have the intercepts so I can plug them into the intercept form, or am I given the vertex and I can plug it into the vertex form? So look at letter A. Our graph passes through 0, 0, 10, 0, and 4, 12. Now, do you notice anything special about any of those points? 2 of them have a 0 as the y coordinate, which makes them our what? X-intercepts. So I want you to highlight, and then I also want you to draw yourself a little arrow, and I want you to write a note. These are your x-intercepts. If I can identify that they have given me my x-intercepts, then obviously I should be using which form to start? Intercept form. Okay? So let's write intercept form down. Again, if you need to flip back to the front of your notes because this is new, we just learned it today, I'm totally fine with that. But what is intercept form? And keep this in mind, we don't need the A in the formula, where our A is going to be an understood 1 at this point. Okay? So what is the intercept form of a quadratic function? F of x or h of x, you can use whichever you want. F of x equals? There you go. So that is the formula or the form we have to start with because we are given the x-intercepts. Now, let's plug in what we know. F of x equals, we already have learned that P and Q are the actual intercepts. So we keep the x and the minus. What is the first x-intercept that we've been given? 0. All right, the 0 right here, the x-coordinate is our P. All right, then x, we keep the x minus. What is the second x-intercept? The 10. Remember, the y-coordinates are zeros. It's the x-coordinate that we're plugging into the formula. So x minus 10. Now, you see two binomials here that are being multiplied. You got to go all the way back to the beginning of chapter 7. How did we learn to multiply two binomials? FOIL. Now do this for me. Draw yourself a little arrow, and I want you to write the word FOIL. But we're going to cross it out. Because of that 0, what is x minus 0? It's just x. So let's not FOIL if we don't have to. But I want you to be aware that right there, typically, if this was any other number but 0, foiling would be the method you would have to use. Okay, so we want it in our notes, but cross it out because right now x minus 0 is x. And then we're going to bring down the x minus 10. Now, how are we going to finish this off? We've got x times x minus 10. A monomial times a binomial. So what do we use to do that? Distributive property. And again, if you're struggling, go ahead and draw those arrows. Show yourself what we have done. So what is x times x? X squared. And what is x times negative 10? Negative 10x. Now, is this standard form? Yes. There's no constant, but that's okay. It has the x squared term and it has the x term. So this is standard form. And that's what they asked us to put it in. Letter B. They tell us that we have a vertex of 8, 8. So really, there's not much thinking involved here. Which form are we going to start with if they've given us the vertex? Vertex form. All right, so again, let's write down the vertex form. Look back at the beginning of your notes if you don't remember it. Again, we don't need the A right now. It's an understood one. So what is the vertex form? Plus k. Very good. F of x equals x minus h squared plus k. Now you say, where do I get the h and where do I get the k? Maybe it's not a bad idea above the vertex for you to remind yourself h is the x coordinate and k is the y coordinate. Just until it's in your brain. All right, so we're plugging in. So let's bring down f of x equals. Let's bring down x minus. What are we plugging in place of h? 8. And what are we plugging in place of k? 8. Now, look at this, guys. This is a special product. So technically, we can write it down x minus 8 times x minus 8. And again, we can FOIL. Or we can use the shortcut that we learned at the beginning of chapter 7. We're going to go the shortcut route in our notes. Remember, if you get to a test or a quiz and you just can't remember the shortcut, x minus 8 times x minus 8, and you FOIL. All right? Shortcut, though. We are supposed to do what with the first term? Square it. What's x squared? Isn't it just x squared? Okay. How do we find the middle term? Now listen, what did we just use to check the middle term? We're going to use the same thing to find the middle term. So how do I find the middle term? 2ab. So what's my a this time? No, remember, your a and b come from your binomial. So what's my a? X, and what's my b? Negative 8, and when I multiply all those together, I get negative 16x. So there's my middle term. Now, what am I supposed to do? I know it's a plus sign. That's the shortcut. The second sign is always positive. What do I do with the second term, the 8? I squared the first term. I did 2ab for the middle term. I'm supposed to do what with the second term? Square it, right? Square the first term, use 2ab for the middle term, square the second term. So what is 8 squared? 64, but I'm not done because I have to bring down the rest of the problem. There's that plus 8 that has to come down. So to finish this off, what is my very last step? Combine like terms. What are my like terms? 64 and 8. So when I combine them, what do I get? 72. Now, is this standard form? Yes, So that is my final answer. And this is lesson 8.5.